Hi there, my name is J.D. Smith. I'm a professor of astronomy at the University of Toledo, and I specialize in the study of galaxies outside of our own, and in particular, I look at the dust and gas in galaxies, which requires using wavelengths much, much longer than those we can see with our own eyes. And what's interesting about this image and what makes it fascinating to me is you're not looking at light from the stars in the galaxy, but instead you're looking at light from what we call dust. And dust is composed of small particles, actually about the size of the particles in smoke. And it's everywhere in the universe, inside of galaxies, including our own. And when that dust heats up, it begins to glow at very long wavelengths. And so the wavelengths we're looking at in this image are more than 10 times longer than the longest wavelengths we can see with our own eyes. And when you have a view of that, as the Spitzer telescope gave us, what you see is a completely different type of galaxy image. You see spiral arms, you see small links between the spiral arms that were not visible before. Really the whole structure of the gas and dust in the galaxy becomes evident. The center of this particular galaxy has a giant supermassive black hole that is gathering material, heating it up to very high temperatures. So you see that sort of small dot down in the center. And it also has this companion with which it will eventually merge up on the top of the image. Now, what's interesting about that companion is actually not a lot of dust in it. I think when you're comparing some of the other wavelengths of views of this galaxy, you'll see that it shows up a lot more in shorter wavelength light from stars directly. And so I think both of them together give you a fantastic sort of diversity of dust, stars, and gas in galaxies, and that's why it's really one of my favorite images in the universe.